This video will cover special right triangles, specifically 45, 45, 90 triangles. Certain right triangles have properties that allow you to use shortcuts to determine side lengths without using the Pythagorean theorem. Let's start with how we would use the Pythagorean theorem to find these shortcuts. First of all, we know this is a 45, 45, 90 triangle because these two legs are the same, which makes it isosceles. And that means that opposite base angles would be congruent. And there's only 90 degrees left from this right triangle to make 45. Knowing this, this could be my A, my B, and my C. So I'm going to start it off as A squared plus B squared equals C squared. Notice I plugged in my X's and my Y's. Next, these are like terms, so we can add them together and get 2x squared equals y squared. Finally, we're going to square root both sides to get the y by itself. When I do that, if I square root x squared, I get a plain x, but I can't square root the radical 2 without going to decimal, so I'm going to leave it as a radical. So this is in simplest radical form. So what we're telling here is the hypotenuse, in this case, was y. All we have to do is take the leg times root 2. Let's see how that works down here. This would be a 45, 45, 90. Means the legs are the same, and I have the length of the leg times root 2. You can use any variable you want here. Let's try example 1a. First of all, what kind of a triangle is it? Well, it's a 45, 45, 90 triangle. I know my formulas for 45, 45, 90 triangles from the first page, and that gives me the leg opposite of the 45 is a leg, and then the other leg is also equivalent to it. And then I have L root 2 from my formula. Let's plug in what we know. My leg is 9. So is my other leg. And now I need to find the length of my hypotenuse. So the next thing I'm going to do is put in an h, because that is what my hypotenuse is in the picture. Next, use my formula that we learned on the first page. The hypotenuse is equal to the leg times the radical 2. Let's plug in what we know. H equals 9 radical 2. I can't simplify this anymore without going to a decimal. So there's my answer, 9 radical 2. Let's try check B. Again, it's a 45, 45, 90 from the picture. So I have that. The next thing is I fill in what I know. Well, my legs are 2 root 2, and since this one's 2 root 2, so will the other one be. So there is my formulas. 2 root 2, 2 root 2, and now that is going to be x. Since my formula from my first page was hypotenuse equals the leg times root 2, I'm going to plug in what I know. My hypotenuse is x. I bring down my 2 root 2, which is my leg, and I multiply it by root 2 because the theorem says so. Next, it's just algebra from here on. I'm going to first multiply the root 2 times the root 2 and get the root of 4, which is 2. So I have 2 times 2, which is 4. Let's try another one. This time, my hypotenuse I know. So, it's what kind of a triangle? 45, 45, 90. I need my formulas. This is my leg, which is x. So my other leg is also x. And my hypotenuse is 6. My formula is hypotenuse equals the leg times root 2. My hypotenuse is 6. My leg is x. And then I pull down the root 2. So now I have 6 equals x radical 2. Well, I need to isolate my x, so I need to get rid of this radical 2. So I'm going to divide by radical 2 on both sides. That will cancel out the radical 2's on the right and leave me with 6 over radical 2. Next, I'm going to bring that up here because we're not quite done. We learned back in a previous chapter that we can't leave radicals in the denominator. So I'm going to bring this up here for more room. We learned a trick. To get rid of radical in the bottom, we need to multiply by root 2 over root 2, since it's the same denominator. Okay? So I'm going to multiply across the top. So x is equal to 6 root 2, we just squish them together. And root 2 times root 2 is a plain 2. Or you can think of it as root of 4, and the root of 4 is 2. The last step is, what can I bring out of a 6 and a 2? I can take out a 2 and leave me with 3 over 1. So my final answer is x equals 3 root 2.